All right, how's it going, team? So this video will be the Safety 1 Homework 1 from the Mod 2 notebook, page 136. So if you're following along, we're going to be on page 136 of the Mod 2 notebook. So Safety 1 Homework 1, Requirement 1, compute pre-occupation low and high angle safety for the following range safety card. So it doesn't explicitly say it on here, but we're going to go ahead and make a square. We're going to solve for both 4 square and for 6 square, right? Because if we're doing pre-occupation safety and it's not specified which square weight we're going to be given, we're going to go ahead and assume that we're going to get 4 square, which is the most common square weight for 795 projectiles. And we're going to go ahead and solve for 6 square, which is the heaviest square weight that a 795 projectile can be, right? So we got to solve for both of those. So we're going to go ahead and follow our 4 basic steps to calculate safety, right? First step is to receive the range safety card, which is right here in front of us. So I always like to grab my highlighter and go through and highlight and annotate a couple of important things that we're going to need to know, right? So first one says here that we are at firing point 166, okay? South Carlton impact area, weapon 155 millimeter, M777 Alpha 2, okay? I'm going to go ahead and highlight that because that's going to send up a red flag in my mind, which is if we're shooting anything other than charge 1, we're probably going to have a muzzle velocity correction we're going to have to worry about. So we'll see what charge we're shooting here in a minute. Okay, so type of fire is both low angle and high angle. So that means I need to go ahead and calculate 2 separate safety T's, one for low, one for high. All right, and then the ammunition we have on hand, right? So I've got my M795, which is my HE projectile in my 795 family. So that tells me I'm going to be using the Alfa Romeo 2 TFT. M231, that's my propellant. That's my max charge or my modular artillery charge system. M231, those are my Lima charges. So I'll probably be using charge 1 or charge 2, which we'll see down later in the range safety card. Then I have M739 Alpha 1, that's my PD fuse that goes with a bursting munition. Makes sense because 795 is a bursting projectile. I have my M767, which is my electronic time fuse that goes with a bursting projectile, right? Makes sense. And then I have a M732 Alpha 2, right? Depending on what version of the homework you have, it'll either say 732 or 732 Alpha 2. Just remember the difference between those 2 fuses is that the 732 can only be set to the whole second, whereas the 732 Alpha 2 can only be set to the even second. Right, so 732 Alpha 2 even second, 732 regular whole second. Okay, so now that I've identified my ammunition, let's go ahead and look down here at my firing data. So firing data, I have my left limit is 300 mils, and my right limit is 5,000 mils, right? So that means that from the firing point, I can only go left 300 mils in azimuth, and then right 5,000 mils to 5,000 mils in azimuth. So what I like to do here is I like to go ahead and just calculate what my azimuth of lay needs to be, right? Because I know my left limit and my right limit. So I got my calculator, left limit 300 plus right limit 5,000 equals 9,300 divided by 2 gives me 4,650. Remember, we always do azimuth of lay or azimuth of fire to the nearest 100 mils. So 4,650 expresses to 4,600, right? So my azimuth of lay is going to be 4,600. And I just go ahead and I calculate my azimuth of lay right then and there, so I don't have to do it later. Okay, so we've got that. All right, let's see. To establish min time for fuse VT, apply plus 5.5 seconds to low angle PD minimum range. Yep, that's standard, right? We do that every single time we're calculating for VT fuses, okay? So my low angle minimum range, let's look at that. Low angle minimum range is 3,200 meters. So that's for my fuse PD and my fuse VT, right? My maximum range, my overall maximum range is 6,800 meters, okay? And then my fuse time and high angle min range is 3,600 meters. So I will use 3,600 meters to calculate my fuse time as well as my min range line for my high angle safety T. Again, that's fuse time and high angle minimum range is 3,600. Okay, so let's go down here. I look at my charges. Low angle minimum charge is charge 1 Lima, maximum charge 1 Lima, fuse time high angle min charge 1 Lima. All right, so it's 1 Lima for this firing point. I can only shoot 1 Lima from firing point 166. which makes it really easy on me. I only have to do one safety T for low angle and one safety T for high angle. This also is going to send up a red flag in my mind, right? Because if I'm shooting an M777 Alpha 2 at charge 1, I probably don't have a muzzle velocity correction, right? Which we're going to review once we get to the safety computation worksheet. Okay, so charge 1 Lima. All right, look down here at the comments. This is super important, right? Because this is where they're going to tell me where my dog leg is. So the comments, from azimuth 4300 to azimuth 4460, the max range is 4800. Okay, so it looks like I'm going to have a max range dog leg. And we'll see what that looks like once we draw it out. All right, so this is my dog leg. Okay, survey data. We're gonna make another square here, right? Survey data, right here it says firing point 253, but this firing point is actually 166. I'm just gonna go ahead and square that in real quick. So firing point 166. Okay, so this is the actual location of the firing point. Not too important to me right now in mod 2. This will be super important in mod 3, but I can see right here in parentheses, it has it in MGRS, right? Military Grid Reference System. So this is like November Delta 5309-3435. And over here, it's in a different format. It's in what we call UTM format, which we'll learn more about in mod 3. But we don't really care about the actual grid as much as we care about the altitude, right? Because this is going to be the battery altitude I'm going to use to calculate sight for this firing point. So right here, it says my altitude is 376.5 meters. But we need to express that to the nearest whole meter. So 376.5, my artillery expressed that to 376. And then I'm gonna highlight that, because that's gonna be super important to calculate my VI and my sight. Okay, so special instructions. It has special instructions for shell illumination. Don't need to worry about this because we're not calculating for illum, right? And then down here it says uncleared ammunition will not be used unless clearance is given by range control. Okay, not too important. We don't really care about that to calculate our safety T data. All right, so now I get down here to the bottom of my range safety card, and I see I have all of my ranges listed, as well as a min altitude and a max altitude at that range. So using my min max rule, I need to go ahead and select which altitude I'm going to use at which particular range. All right, so at range 3200, let's see here, range 3200 is a minimum range. So min max, minimum range, max altitude. So at range 3200, I'm going to use max altitude 420. Okay. Next, I have 3600. So what is 3600? 3600 is a minimum range. Using the min-max rule, min range, max altitude. So at 3600, I'm going to use altitude 400. Next, I have range 4800. 4800 is a max range. So max range, min altitude. So at 4800, I'm going to use min altitude 400. And then finally, I have max range of 6800, which is my overall max range. So min max rule, max range, min altitude. So 6800 will have min altitude of 420. Okay, so I've completed step 1. I have received my range safety card, and I have identified all of the pertinent information I'm going to need to transfer over to my safety computation worksheet for step 2. Okay, so we'll go ahead and move on to step 2. All right, so we've already completed step 1, which is to receive our range safety card, and we've annotated all the pertinent information. Now we're going to move on to step 2, which is to construct our basic safety diagram, right? So to do that, I'm going to go ahead and grab a straight edge, and then we're just going to transfer over some of the pertinent information from the range safety card over here to my safety computation worksheet, okay? Starting with the location. So the location we said was firing point 166. And the grid for that down here is 5309, 3435. Okay, altitude, super important, right? Altitude, battery altitude is 376. We're gonna need that for sight. We're shooting charge 1 Lima, and fuse is gonna be PD, time, and VT. Okay, and then my azimuth of lay, which we've already calculated over here, azimuth of lay is gonna be 4600. As soon as I record it here, just pop that right down here and record it. Azimuth of lay 4600. Okay, so now we need to go ahead and construct our basic safety diagram. So I see my, I always like to start with my min and max ranges, and then my left limit and right limit, and then I make my dog leg. So my low angle minimum range is 3200. So I'm gonna grab my straight edge. This is not an advertisement for Ranger Joe's. I just like using their protractors. Okay, so this is my min range, right? We said min range 3200. and we solved for max altitude 420. Okay, so now I've got that. So now I'm gonna go ahead and I'm gonna lightly draw my left and right limits because I know I have a dog leg somewhere. So I'm just gonna go ahead and lightly draw my left and right limits. And I'm gonna do my max range. Okay, and we said max range, the overall max range was 600 to 800 meters. And the min altitude, we said, was 420. Okay, so I know this over here, this is gonna be my azimuth on the left, which we said was 4,300 is my left limit. And I'm gonna have to convert that to deflection here in a second, so I'm just gonna record that. Over here, my right limit, my azimuth, we said was 5,000. And I'm gonna have to convert that to deflection, so I'm gonna go ahead and record that there. Okay, so now I need to take care of my dog leg. I'm gonna do my dog leg before I do my min time range for reasons that you'll see, especially when you have minimum range dog legs. But let's see here, so the comments from azimuth 4,300 to 4,460, max range is 4,800. So let's see here, oh yep, so that's 4,300 to 4,460. 4,460 is still gonna be left of my center line, so that means that it's gonna have a chunk taken out of it right here. So I'm just gonna go ahead and erase this here. I'm just gonna go ahead and create this dog leg real quick. Do like that, and put it right here like that, okay? So we said this, this azimuth here, so it's from 4,300 to 4,460, and I know that I will have to convert that to deflection, so we'll go ahead and record that there. And we said that this was a max range dog leg, right? So that's max range of 4,800, right? 4,800 with a min altitude of, getting kind of cramped here, 400 is what we said. Min altitude 400. Okay. So now that I have my basic safety diagram generally done, I'm gonna go ahead and put in my min time range line. My min time range line, where did we say that was 3,600. Okay, 3,600 is below this. Okay, so that means that it's probably gonna be somewhere like right here. None of this has to be to scale. It doesn't necessarily have to be like super pretty. It's just a tool for us to use to be able to organize kind of the ranges and visualize what the safety box looks like, right? So min time range is 3,600 meters. Okay. So now that I have that, I need to go ahead and convert all of my azimuths to deflection, right? And the way that I do that is I go ahead and draw arrows from the center line, which is our azimuth of fire, which represents azimuth of fire 4,600, right? So let's go ahead and do, I like working from left to right. So we're gonna take 4,600 and we're gonna go left. So we're gonna draw an arrow going to the left. I'm gonna record left there. Okay, so now, what does it take to get from azimuth 4,600 to azimuth 4,300? So what I do is 4,600 minus 4,300. I have to go left 300 mils. So left 300. Okay, next I'm gonna go ahead and work on my next azimuth, working from left to right. Yep, so the arrow is pointing to the left. So what does it take to get from 4,600 to 4,460? So 4,600 minus 4,460, I have to go left 140 mils. So left 140. Okay, and now I've got these two azimuths taken care of. I need to go ahead and take care of this one right here. So I need to move to the right, okay, to the right. And now it's, how do I get from 4,600 to 5,000? So I take 5,000 minus 4,600, which gives me 400 mils. I gotta move right 400 mils. Right? Literally, I'm drawing the arrow to the right because I'm talking in azimuth right now. We haven't switched to deflection yet. Remember our Rawls rule for azimuth, right add, left subtract. Okay, so now that I've drawn my arrows, I can go ahead and do my math to convert these azimuths to deflection. So looking at deflection, my azimuth of lay is 4,600, which means my common deflection will always be 3,200. So 3,200 left 300, right? I gotta remember now I'm talking in deflection, because I'm solving for deflection right here, I got to remember my Lars rule. Who invented deflection? He was an asshole. His name is Lars, some German guy, right? So 3200 left 300, so that's 3200 left add, so 3200 plus 300 gives me deflection 3500. Okay, and then I know I'm gonna have to add drift down here later on. Okay, so I've got that. Next, I need to go deflection 3200 left 140 left add. Okay, so 3200 plus 140 is 3340 for my deflection here. 3340. Okay. Now I go deflection 3200 right 400. So remembering Lars, left add, right subtract. So 3200 minus 400 gives me deflection 2800. Okay, cool. So now I have my basic safety diagram constructed. And I have all of my ranges labeled with the appropriate altitudes. I've labeled my left and right azimuth limits, and I've converted them to deflections. So step 2, construct the basic safety diagram is complete. Now we can move on to step 3, which is to go ahead and calculate using our basic safety computation worksheet. All right, so now we're moving on to step 3 to go ahead and fill out our safety computation worksheet. So I probably don't need the range card anymore. All right, so we're gonna start off by filling out some of the admin data up here. So what charge are we shooting? We already identified that, that's charge 1 Lima. Shell is gonna be HE, specifically it's gonna be Mike 795. Fuse, PD, time, VT. All right, projectile family. What projectile family is the 795 in? The Mike 795 projectile family. That means the TFT that it uses is the Alfa Romeo 2, specifically part 1 of the Alfa Romeo 2. Okay, next I come down here and I see I have my computation workspace to see if I have any range corrections for any non-standard conditions. Right, so the 2 non-standard conditions that I care about for pre-occupation safety is square weight and muzzle velocity corrections. So my square weight, the first square weight I'm solving for is 4 square, which is standard, right? So I don't need to worry about doing this for square weight. But I need to go ahead and check to see if I need to get a range correction for muzzle velocity. So what I'm gonna do is I'm gonna go to my Alfa Romeo 2. I'm gonna refer to my Alfa Romeo 2. I'm gonna turn over here to Roman numeral page 9, and I'm gonna see that I have my change in muzzle velocity, right? I see here I have a couple different weapon systems. The only one I care about is the M777 Alpha 2 because that's the one that I'm shooting according to the range safety card, right? Remember that the TFT is based off of the standard weapon system of the Paladin, right? So I always have to make sure if I'm shooting something other than a Paladin to come to Roman numeral page 9 to see if I have a muzzle velocity correction, right? So I look here, I'm shooting M777 Alpha 2, I'm shooting charge 1, so I see that I do not have any muzzle velocity correction I have to worry about for charge 1. And you can see that I would have one of plus 1 meter per second for charge 2, and then plus 2, 4, and 2 for charges 3, 4, and 5, respectively, right? But for this one, I don't have anything that I need to worry about right now. So that's great news for me because that means that it's gonna save me time interpolating. I can just extract some stuff from Table Fox when we get down here for this part. So I don't need to worry about any of this stuff up here. So I can just move right down here. So I'm gonna start off by calculating for my diagram ranges and my entry ranges, right? Diagram range is literally the range from the diagram. It's the exact same thing as chart range, right? So diagram range, I always start small and go large. So diagram range of 3200 is the first one that we have. Diagram range 3200 plus any range corrections. Do I have any range corrections? No, I do not. So plus 0 gives me a total range of 3200 multiplied times range K. I don't have a GFT setting that I'm using right now, so I'm just going to use 1.0000, which gives me an entry range of 3200, right? Diagram range is super important because I use diagram range to calculate sight, but then I use entry range to calculate everything to the right of the solid black line. Okay, so that's why I go ahead and solve for both of those right here. All right, so let's go to our next diagram range. Next diagram range is range 3600. So 3600, do I have any range corrections? No, I do not. 3600 plus 0 gives me 3600. multiplied times range K of 1.0000 gives me entry range of 3600. Okay, let's go to our next diagram range. Next diagram range is range 4800. Do I have any range corrections? No, I do not. So that gives me total range of 4800 multiplied times range K of 1.0000. It gives me an entry range of 4800. Okay, so that one's good to go. Now I just need to record my last diagram range of 6800. Do I have any range corrections? No, I do not. Which gives me total range of 6800 multiplied times range K of 1.0000 to give me an entry range of 6800. Okay, so now that I have recorded my diagram ranges and calculated my entry ranges, I can go ahead and move on to calculating site. So let's start with diagram range 3200. So I'm going to be using charge 1 Lima for all of my ranges. So I'm just going to go ahead and record that real quick. Okay, so I'm using charge 1 Lima for all of my ranges. So let's go ahead and solve for our VI for diagram range 3200. Remember, VI, the equation for that is target minus battery. In this case, it's the altitude of the min range line minus the battery altitude. So we said that our altitude here was 420 minus the battery altitude of 376, which gives me a VI of positive 44. Don't forget to carry that sign, right? VI, the sign is super, super important. Okay, so VI of positive 44. Now I just need to find my site. The preferred method for calculating site in bulk is using the GST, right? So let's go ahead and set off a VI of positive 44. Okay, now I'm going to use diagram range, right? Because I'm finding site, use diagram range of 3200 for charge 1 at target above gun. So diagram range of 3200. So that's 3000, 31, 32. Okay, so now I extract my three numbers. Three numbers over here at my martini glass look like 146. Okay, so 146. Now I just need to place the decimal to make the site as large as possible without surpassing the VI. So that'd be 14.6. Right, 14.6 is as large as possible without surpassing positive 44. So 14.6, but we always express site to the nearest mill. So 14.6 expresses to 15, specifically positive 15. Right, and right now I'm going to do a sanity check for myself and make sure that the site is not larger than the VI because we're under range 10,000, right? And we're low angle. And the site has the same sign as the VI for low angle. Yep. Makes sense. Passes the sanity check. Okay, so now that I have that, let's move on to diagram range 3600. So diagram range 3600. Do I need to solve for site for range 3600? No, because I only use the min time range to calculate my min time fuse setting over here. So I don't have to solve for VI or site at that range for low angle. Okay. For diagram range 4800, let's go ahead and solve that one right there. So first thing I need to do is I need to find my VI. VI is target minus battery. We said that the altitude at range 4800 was 400. So 400 minus battery altitude of 376 gives me 24, specifically positive 24. Remember to carry the sign for VI. So positive 24. Let's go ahead and find site. So VI of positive 24. So go ahead and set off VI of 24 over here on, there we go, there on the D scale. And then I'm at range 4800, charge 1, target above gun. Okay, so let's see here. It looks 45, 46, 47, 4800 right up there. Target above gun on the C scale for charge 1. Then over here, I go ahead and extract my three numbers from the martini glass, right? So the three numbers I extract there, it looks like 601, 602, something like that, right? Now I just need to, we'll call it 602, place the decimal so it's as large as possible without surpassing the VI, so that'd give me a site of positive 6. All right, sanity check, is positive 6 less than the VI of positive 24? Yep, makes sense. And does it have the same sign as the VI? Yes, it does. For low angle, the site always has the same sign as the VI. All right, so now let's move on to our last diagram range of 6800. So first things first, let's find the VI. Diagram range 6800 has an altitude of 420. So 420 minus battery altitude of 376 gives me a VI of positive 4, 4. Positive 4, 4. Okay, so let's go ahead and find sight. So set off my VI of positive 4, 4 on the D scale. All right, now I'm shooting charge 1, target above gun because the VI is positive. Let's see here. Range 6,800. Okay, so I see that the last listed range here on my GST for charge 1 is range 6,600. So the range that I need is not listed on the GST. Right? Anytime that the range is not listed on the GST, or I'm shooting a charge that is not listed on the GST, what does that mean I have to do? I have to calculate my sight manually. Okay, so let's go ahead and refer to your handouts that your gunnery instructor probably gave you, or it's in your notes, or you can find this in the quadrant elevation theory slide deck, right? Or you can find it in your .81 for the manual computation of sight step action drill. So manual computation of sight. Let me go ahead and get out my scratch paper here. So for manual computation of sight, I see the first thing I need is my VI, which I already have. VI, we said, was positive 4, 4. Okay, so this is going to be low angle sight for range 6,800. It's always good to keep your work organized. So whenever you turn in your exam or your homeworks, your gunnery instructor can go back and try and see where in the process you got your information incorrect, if you got it incorrect, right? So low angle sight for range 600, okay? So first thing I need my VI, right? We said our VI was positive 4, 4. All right, cool. Next, I need my angle of sight. I can find my angle of sight one of two ways. I can either do it manually or I can use my GST. I prefer to do it manually, but that's just me. If you're high speed and like using your GST to find angle of sight, that's totally fine, right? But my angle of sight is equal to VI over range in thousands, so positive 4, 4, over range in thousands, which is 6.8, multiplied times 1.0186, or smart guy factor, right? So let's plug that in. So 4, 4 divided by 6.8 equals some disgusting number times 1.0186 equals another disgusting number, okay? But I look over here and I see that angle of sight is always expressed to the nearest tenth of a mil. So 6.5909411 expresses to 6.6, and make sure that I always have the appropriate sign. I know my angle of sight is always going to be the same sign as my VI. So angle of sight is positive 6.6. Okay, so 6.6 for range 6,800. So now that I have my angle of sight, I need to get my complementary angle of sight. All right, so my complementary angle of sight, the equation for that is the absolute value of the angle of sight multiplied times the complementary sight factor. So absolute value of positive 6.6, which is 6.6, multiplied times my comp sight factor. My comp sight factor I get from table golf and my Alfa Romeo 2. So I'm going to go ahead and extract my Alfa Romeo 2. I'm going to turn to charge 1. I'm going to find table golf. Let's see here. It's table Fox. Table golf for charge 1. Right? Also called the FDO's table because there's a lot of nerd stuff in here, right? So I need complementary sight factor for diagram range 6,800. So I come in here. I see that I have my rockstar line. I'm shooting low angle, so I want to stay above the rockstar line, right? See here, so range, so 6,800 is not a listed range here in table golf. So what I'm going to do is, if it's not an available, or it's not a listed range, it's beyond or below the first or last listed range, I'm just going to use the last listed range here. So I'm just going to use the comp sight factor for range 6,500. So I come over here and I need to extract the number either from column 1-2 or column 1-3. So I know that I am target above gun, right? Because it's a positive VI, target above gun, so I'm going to extract it from column 1-2. So that gives me a complementary sight factor of 1, specifically positive 1.259er. Okay, so now let's go ahead and plug that in. So absolute value of positive 6.6 is 6.6 multiplied times positive 1.259, which gives me a complementary angle of sight of 8.3094, which when I look at my step action drill, that always expresses to the nearest tenth of a mil. All right, so that would equal positive 8.3. Okay, so now that I have my complementary angle of sight, I just need to combine my angle of sight and my complementary angle of sight to get my overall sight. So that's positive 6.6 plus positive 8.3. And what does that give me? 6.6 plus 8.3 gives me 14.9, positive 14.9. But I know I always need to express sight according to the step action drill to the nearest mill. So positive 14.9 expresses to positive 1.5 mils. Okay, so my sight for diagram range 6800 is positive 1.5. All right, quick sanity check. Is the sign on the sight the same as the sign of the VI? Yes, it is. They're both positive. They're always the same for low angle, right? Is the sight as large as possible without surpassing the VI? Yes, it is, right? So especially when you calculate manually, the rules kind of still apply, right? So if I was to calculate my sight and I got some wild number like positive 215 and it was larger than the VI, I know I probably messed up my arithmetic somewhere over here. So I would go back and I would just double check my work. Okay, let's go ahead and block that off now that we're done. Okay, so now that I have my sight, I am done with my diagram ranges. So what I like to do, even though the diagram range and the entry range is the same here, I always like to grab a Post-it note and I tell my students to cover up your diagram range, right? Diagram range doesn't matter anymore, at least right now, right? Because when we cross the solid black line, what do we use? We use entry range to find everything to the right of the solid black line, right? So first thing we need to do is we need to find what data we need for entry range 3200. So at range 3200, what do I need? I need elevation, right? Because I need to find my min QE. So where do I extract elevation from? It's table Fox of my Alfa Romeo 2. So I'm going to refer to my Alfa Romeo 2. Let's go to table Fox for range 3200, entry range 3200. Okay, at entry range 3200, let's see if I can get this on the camera a little bit better. Entry range 3200, I see that I have an elevation of 216.5. So as a general rule of thumb, anytime that I extract a number from the TFT, that's when I express it, right? So 216.5 expresses to the nearest whole mil for elevation, right? So 216.5 expresses to 216. So elevation 216. Okay, so now I need to find quadrant. Quadrant is the summation of sight and elevation. So elevation is 216 plus positive 1.5 for sight, which gives me a quadrant of 231. Now, a good habit that I tell my students to have is anytime that I calculate something that's going to go on my safety tee, I circle it, right? So I know quadrant is going to go on my safety tee, so I circle it. You circle it because when you get down here and you start filling out your safety tee, you don't want to accidentally use your elevation on your safety tee instead of your quadrant. I've seen it happen dozens of times with students, right? So I say, as soon as you find something that goes on your safety tee, go ahead and circle it, okay? So moving from left to right, do I need a electronic time min time fuse setting for range 3200? No, because I can only shoot time fuses starting at range 3600, so I don't need that, right? I don't need that. Now, what about a VT fuse setting? I absolutely do, right? Because I calculate my min VT time using my PD min range line, right? Because my VT time fuse setting is a function of the time of flight for my min PD range, which is 3200, okay? So to do that, I got to find my time of flight for range entry range 3200, right? So time of flight is found in table Fox. So look down here at range 3200. I come over here to column 7, and at range 3200, time of flight is 12.2. So 12.2. Then I add my 5.5 second safety buffer for my VT fuses, right? Because the VT fuse arms 5.5 seconds before it functions, right? So I'm going to do 12.2 plus 5.5. It gives me 17.7, so I'm going to record that there. And now what I do is I express this number up to the next whole second, which in this case would be 1/8, but it's always a VT fuse. VT fuses always end in 0.0 for their time fuse setting, right? So VT time fuse setting of 18.0 is my min VT time fuse setting for entry range 3200, okay? Now, do I need to find my drift for entry range 3200? Yes, because I need the least left and most right drift. So I'm gonna find drift for my min range and find drift for my max range, okay? So drift for entry range 3200, let's look at that. Drift for entry range 3200 looks here in column 8 to be 4.3. I always express that to the nearest whole mil as I extract it from the table. So that's going to be 4, and drift is always to the left. Always to the left. Drift is always to the left. So that's going to be left 4. Okay. So now I'm done with entry range 3200. So let's move down to entry range 3600. So do I need to find elevation and quadrant at range 3600? No, because I only need to find my min time fuse setting for that line. So I don't need elevation, I don't need quadrant, I don't need time of flight, I don't need a VT fuse setting, and I don't need drift. All I need is a time fuse setting for range 3600. So where do I find my time fuse setting? That's in table Fox, right? So I'm gonna go ahead and find entry range 3600, right? Entry range for everything to the right of the solid black line. So 3600, right here, I go to column 3. Fuse setting for Gray's burst would be 13.9. 13.9. Okay, so now that I have that, I am done with entry range 3600. Now let's go to entry range 4800. So what do I need at range 4800? All I need is elevation and quadrant, right? I just need my max quadrant for that max range dogleg. So I don't need time fuse setting, I don't need time of flight, don't need VT, and I don't need drift because it's not the overall max range. I just need drift at the minimum range and the maximum range. That's it. Okay, so let's go ahead and use entry range 4800. And my Alfa Romeo 2, look in column 2, and it gives me elevation of 358.2. 358.2, as I extract it, I express it. 358.2 expresses to 358. Quadrant is the summation of height and elevation, so now I take positive 6 plus 358, which gives me a quadrant of 364. Oh, I broke my own rule earlier, right? So anytime we find a value that we're gonna put on the safety tee, we're gonna circle it, right? So I'm gonna circle quadrant 364. I'm gonna circle my min time fuse setting. Then I'm gonna circle my min VT time fuse setting. All right, broke my own rule. Okay, so now I'm done with entry range 400. Let's move down to entry range 6800. So at 6800, what do I need? I need my quadrant. So let's go ahead and solve for that. So at entry range 6800, elevation, let's find that in table Fox. Entry range 6800, okay, it's not listed here. Let's see if it is on the next page. Yep, so entry range 6800 gives me an elevation of 690.3. Express it as I extract it. So 690.3 expresses to 690. Okay, quadrant is the summation of height and elevation, so positive 15 plus 690 gives me a quadrant of 705. It goes on the safety tee, so I'm going to circle it. All right, so do I need a time fuse setting or VT time fuse setting? No, I don't need max time fuse settings. I don't need those, but I do need my drift. I need the most right? I need the most drift. So what is my drift for entry range 6800? Entry range 6800, drift would be column 8, and it looks like 18.0. Express it as I extract it, so that is left 18. Remember, drift is always to the left, okay? So left 18. So now that I have that, I can go ahead and take these drifts and I can apply them to my deflections up here. I just need to figure out which drift goes with which deflection, okay? So let's go ahead and remove this. So remember the rule for applying my drifts. For applying my drifts to my deflections, it's least left, most right. So the way that I do this, I always start moving left to right with my deflections. So starting with deflection 3500, which is on this line right here. So on deflection 3500, which side is open, right? Which side is open to take the deflection or the drift, right? In this particular case, the left side is open, meaning that everything to the right of this is all inside the safety box. This is closed, right? All this is closed. The left is open, so that means least left. Least left, so that's left 4. So 3500, least left, so I'm gonna do left 4. I'm gonna add the drift, so 3500 plus left 4. Remember, who invented deflection? Lars, because he's an asshole, right? 3504. Left add, right subtract. So 3504. And that's going to be a safety T value, so I'm going to circle that. Okay, So now I go to deflection 3340. Now I need to determine if I need to use my least left or most right. So at deflection 3340, which side of the deflection is open? Left side. The left side is open, right side is closed. Right side is inside the box. That's not what I want. Left side is open, so I can apply least left. So 3340, least left is left 4. 3340 plus left 4, remembering left add, right subtract for deflection. So that's 3, 3, 4, 4. It's getting kind of crowded over here. It's a safety T value, so I'm going to circle it. Deflection 3344. All right, so now I have one more deflection. I have my deflection over here, my deflection 2800. So let's figure out if I use least left or most right. So at deflection 2800, which side is open? Left side or right side? Well, looks like left side is closed. My right side is open. So that means I'm going to use most right. Least left, most right. So I'm going to use my most right, which is 1/8, my highest value for drift. So left 1/8. So now I take 2800 plus left 1/8, remembering left add, right subtract, so that's 2818. And that is a safety T value, so I'm gonna go ahead and circle that, okay? So now this concludes our 4 square, right? Our lot alpha, we'll just go ahead and call this like 4 square lot alpha, just so I don't get confused here. So 4 square lot alpha. But what do we need to do? We still need to solve for 6 square, or our lot bravo, right? So 6 square lot bravo is gonna be down here. So 6 square lot bravo. So now we need to do some total range corrections for that. All right, so now we need to go ahead and solve for 6 square lot bravo, right? So what I have to do is I have to go ahead and account for that non-standard condition because we have a different square weight, right? So I'm gonna do that in this computational space right here. We're transitioning from 4 square up here, 4 square lot alpha, down here to 6 square lot bravo is what we're gonna call that, right? So which ranges do I actually need to solve for? I don't have to do all of them, right? Generally speaking, especially at lower charges, a heavier projectile is not going to go as far when I shoot it with the same charge at the same elevation, right? So I really only need to find anything that has a minimum range. So of my ranges I have on my basic safety diagram, I only have 2 min ranges. I have min range 3200 and min range 3600, okay? So diagram range 3200 and diagram range 3600, okay? All right, so now I have that. What charge are we shooting? We're shooting charge 1 Lima for both ranges, right? And what is my non-standard condition? That means what am I trying to account for? I'm trying to account for 6 square, right? Both of them, 6 square. Minus my standard condition. What is my standard square weight? My standard square weight is 4 square. So 6 square minus 4 square gives me a change in standard, right? So 6 minus 4 is positive 2, but in this case, we call that an increase of 2 square, meaning that what I'm trying to solve for right now is an increase of 2 square from standard of 4, right? So now that I have that, I need to go ahead and find my diagram range correction. So where do I find the range correction for an increase of square weight or an increase in muzzle velocity? I find that in table Fox, right? So I'm going to extract my Alfa Romeo 2. Let's go ahead and go to diagram range 3200. Okay, so at diagram range 3200, let's see here. I look all the way over to the right. I'm here on page 125 in my Alfa Romeo 2. And I see that I have 2 options. I have column 1.8 and I have column 1.9, which is projectile weight of 1 square. Column 1.8 says decrease, column 1.9 is increase. What did we say? We have an increase of 2 square. So at range 3200, my increase value is positive 2.3. Make sure we carry that sign. So at 3200 is positive 2.3. Okay, so positive 2.3. Now what is it for range 3600? Okay, let's see here. Nope, it's not on this page. So let's turn to the next one. So I'm on page 127. So at range 3600, I look all the way to the right. Remember, column 1.8 is decrease, column 1.9 is increase. And we said we had an increase of 2 square, so 3600. Increase is positive 2.5. All right, so I'm gonna record positive 2.5 here. All right, so now that I've extracted those values, I just need to do some math, right? So it says, I go ahead and take my increase of 2 square multiplied times my diagram range correction, right? So that's 2 times positive 2.3, which gives me positive 4.6. I'm gonna go ahead and record, always record the value the calculator gives you. And then you're going to express that to the nearest 10 meters, right? Because that's how we always express range. Range is always expressed to the nearest 10 meters. So positive 4.6 expresses to positive 50. Okay, so now let's go ahead and do it for diagram range 3600. So I take 2 times positive 2.5, which gives me positive 50. Always record the range or the value that it comes out of your calculator, and then we express it, but that's already expressed nearest 10 meters, so I don't need to worry about that, okay? So now that I have my total range corrections down here, I can go ahead and bring these down here to calculate my entry range. So for 6 square lot Bravo, let's look at the 2 diagram ranges we're calculating for. We're calculating for diagram range 3200, so let's do that one first. 3200 plus, do I have a range correction? Yes, I do. Range correction of positive 50 gives me a total range of 3250. Do I have a GFT setting? Nope, so that's 1, multiply that times 1.0000. I don't have range K. So 3250 multiplied times 1.0000 is 3250. Okay, so next diagram range is 3600. Do I have a range correction? Yes, I do. I have a range correction of 50. Hold on here, 3600. Yep, 3600, yes, positive 50, so 3650. Just making sure I extracted the correct value from the TFT, right? The most common mistake that folks make is they extract the wrong value from the TFT up here, and if they do that, then all of this is going to be wrong, right? So you always want to double check that you're extracting the correct values from the table Fox right here, or it's just going to compound, and then everything that you solve down here will be incorrect, and then your safety T will be wrong, right? Okay, so I don't have range K or GFT settings. It's 1.0000. Gives me an entry range of 3650, okay? So do I need to go ahead and recalculate for sight? No, I don't, right? Because sight is a function of diagram range, which I already did up here. So I can, as long as I did this correct up here, I can just carry it down, right? So charge 1 lima, my VI is positive 4.4, and my sight was positive 1.5 at diagram range 3200, because I'm left of the solid black line. Right, what about at range 3600? Do I need to calculate sight for range 3600? No, because I'm just using range 3600 to calculate my min VT time fuse, my min time fuse setting, right? So got that. Let's go ahead and move to the right of my solid black line, which means from here on out, I'm gonna use my entry range. So I'm gonna go ahead and grab a sticky note. I'm gonna cover up my diagram range. I don't need my diagram range anymore, right? I just need to worry about my entry range. Okay, so at entry range 3250, what is my elevation? All right, so let's go ahead and extract my Alfa Romeo 2. Elevation is in table Fox. Let's see if range 3250 is a listed value. So range 3250. Okay, so 3250 is not a listed value in column 1. I'm on page 124 of my Alfa Romeo 2. So what does that mean? That means I'm gonna have to interpolate, right? Pretty much any time that I have any sort of range corrections, I'm gonna have to interpolate all my data to the right of the solid black line, okay? So let's go ahead and put this up here. Let's go ahead and extract our scratch paper. Okay, so right now I'm trying to solve for elevation for entry range 3250. So 3250. Okay, so it's not a listed value, but what values does it fall between? 3250 falls between range 3200 and range 3300, right? So I'm trying to find what elevation is associated with range 3250. I don't know that yet. That's what I'm going to solve for. But I do know what it is for 3200, right? Which is what? 216.5. And then for 3300 is 224.4. Okay, so now that I have this set up, I can go ahead and set up my brackets, right? I always do top to bottom as listed in the table. You always interpolate from top to bottom as listed in the table. So 3200 over 3250 is a difference of 50, right? 3200 and 3300 is a difference of 100, okay? And then over here, what is this? We don't know what that is, We're calling this x. That's what we're about to solve for, right? So then I have my big bracket. So what is the difference between 224.4 and 216.5? So that would be 224.4 minus 216.5 gives me 7.9. Right? I always use absolute values when I interpolate, so I don't have to ever deal with negative numbers, right? So now that I have my bracket set up, the ditty I use is little over big equals little over big. So little bracket over big bracket. So little bracket is 50, big bracket is 100. Little over big equals little, here is x, right? Little over big, big is 7.9. So now that I have this, I just need to cross multiply, right? I'm going to multiply 7.9 times 50 and divide it by 100. Okay, so 7.9 times 50 divided by 100 gives me x equals 3.95. And remember, express at the x. I always have to express right here, right? So 3.95 expresses to the value that's listed in the column I'm trying to solve for, right? These are both listed to the nearest tenth of a mil. So I'm going to express this to the nearest tenth of a mil, right? Which in this particular case, 3.95, what does that 5 turn that 9 into? That turns that into a 10, which bumps that up to 4. So that would be 4.0, right? So x equals 4.0. Now, what do I do with that 4.0? I have to apply that to 216.5 in such a manner that it puts the value that I'm solving for in between 216.5 and 224.4. So in this particular case, I just need to add it, right? So 216.5 plus 4.0 gives me 220.5. So that means that at entry range 3250, the elevation would be 220.5. So I'm going to go ahead and record my elevation down here. And I need to remember that elevation is always expressed to the nearest mil. So 220.5 expresses to 220. Okay, so now that I have elevation, I'm going to go ahead and mark that off. Now that I have my elevation, I need to find my quadrant. Quadrant is the summation of site and elevation. So I take 220 plus positive 15, which gives me a quadrant of 235. Quadrant is a value that's going to go in my safety T, so I'm going to circle that, okay? Do I need to find my min time fuse setting for range entry range 3250? No, right? Because this is not where I'm finding time fuse setting. That's going to be at 3650. But I do need to go ahead and find a VT fuse setting, right? Because my VT fuse setting is a function of my min range line. So what is my time of flight at entry range 3250? As we can see up here, 3250 is not a listed value. So what does that mean we have to do? We have to interpolate, right? So 3250, give myself a little bit more room here. So 3250 is not a listed value, but it does fall between 3200 and 3300, right? I'm over here looking in column 1. 3250 falls between 3200 and 3300. And the time of flight, which I'm going to extract from column 7, right? So at range 3200, time of flight is 12.2. I don't know what it is for 3250, that's what I'm trying to solve for, right? And then time of flight for range 3300 is 12.6. Okay? So now that I have my values extracted from my columns, I can go ahead and set up my brackets. So the difference between these two is 50. The difference between these are 100, right? And then the difference between these, I don't know, so I'm calling that x. The difference between these, so 12.6 minus 12.2. Again, I always use absolute values, so I don't have to deal with negative numbers, is 0.4. Okay? And remember, always interpolate from top to bottom as listed in the table, right? Top to bottom as listed in the table. So now that I have this, I can go ahead and set up my equation. And remember the ditty, little over big equals little over big. So little bracket, 50, over big bracket, 100, equals little, which is my x, over my big bracket, which is 0.4. Little over big equals little over big. So now I just cross multiply. I'm going to take 0.4, multiply it times 50, and divide by 100. So 0.4 times 50 divided by 100 gives me x equals 0.2, and I always express at the x. I express as listed as the values in the table. So if I look in this column, these values are listed to the nearest tenth of a second, and so I just need to express this to the nearest tenth, and it's already there, right? So 0.2. Now I just need to apply it up here so that the value that I'm solving for falls between 12.2 and 12.6. So that's going to be adding 12.2 plus 0.2 gives me 12.4. Quick sanity check, does 12.4 fall between 12.2 and 12.6? Yes, it does. So that means that my time of flight, that's what I'm looking for right there. All right, so time of flight is going to be 12.4. Okay, now I take 12.4, I add my 5.5 second VT safety buffer, which gives me 17.9, which then expresses up to the next whole second for VT. So 17.9 expresses up to 1.8, and it's VT, so it always has to end in 0.0. That's a safety T value, so I'm going to go ahead and circle it. Okay. Do I need to solve for drift? No, because I only solve for drift using my ranges up here. I don't have to recalculate drift for total range corrections, okay? So I don't need drift. I don't need to do that. And the reason for that is with a heavier projectile, has more inertia, so it is less affected by the drift that is caused by the spin of the projectile, right? So I mean, we could go through and solve it if we wanted to, but I know that this is going to be the more restricted drift regardless. Okay, so I don't need to solve for drift anytime I'm solving for a heavier projectile. Okay. All right, so let's move on to our next one. Entry range 3650. What values do I need here, right? I just need my time Q setting. I don't need elevation or quadrant, and I don't need time of flight, VT, or drift. I just need my time Q setting. So at range 3650, what is the time Q setting? So 3650, let's go to our Alpha Romeo 2 table Fox, because that's where we find our time Q setting. All right, so 3650. Is 3650 a listed value? No, it's not, but it does fall between 3600 and 3700. So I'm gonna go ahead and set that up. I'm trying to solve for 3650, but it falls between 3600 and 3700. Always record it in your notes as it's listed in the table, right? So 3600 is on top of 3700, so it's 3600, 3650, 3700. All right, and now I'm trying to find the time fuse setting for 3650. I don't know what that is, right? So I'm gonna put a little blank there. But I do know what it is for 3600, right? 3600 time fuse setting in column 3 is 13.9 seconds. Time fuse setting for range 3700 in column 3 is 14.3 seconds. All right, so now I have my values recorded. Let's go and set up our brackets, right? What does it take to do this? This is 50, this is 100. I don't know what this is, so I'm solving for X. And this up here, 14.3 minus 13.9 gives me 0.4. Now that I have that set up, let's set up our equation. Little over big equals little over big. So little bracket over big bracket equals little bracket over big bracket. Okay, now that I have that, just cross multiply. 0.4 multiplied times 50 divided by 100. And that equals X equals 0.2. Okay, so 0.2, I need to express at the X, right? Express to the value listed in the table. So in the table, they list it to the nearest tenth of a second. I'm already at the nearest tenth of a second, so it's already expressed. So now I just need to apply it so that the value that I'm solving for falls between 13.9 and 14.0. So that means I'm just gonna add it. So 13.9 plus 0.2 gives me 14.1, right? Sanity check time, does 14.1 fall between 13.9 and 14.3? Yes, it does. So that passes the sanity check, okay? So now I just take 14.1, and that is my min time fuse setting for entry range 3650 for my 6 square or my lot Bravo, okay? So now I am completely done with step 3, which is to solve for all of my data using the computation or safety computation worksheet, right? So now I just need to move on to step 4, which is to issue the safety T. Okay, so issuing the safety T, super simple. I've already solved for all my values. I just got to transfer it down here. So I'm going to start with the administrative data, right? So let's see, location is firing point 166, which is 5309, 3435, altitude 376, charge 1 Lima, shell HE, fuse PD, time VT, azimuth of lay 4600. All right, so now I need to fill out my safety T. So I always start with my deflections. Always start with deflections. It makes it a lot easier. And we always start, just like we do anything with deflections, we start from left to right. So how many deflections do I have total? I have 1, 2, 3 deflections total. So that means I'm gonna go ahead and separate this deflection block into three equidistant little blocks, right? To make room for my 3 deflections. So leftmost deflection is 3504, so I put that on the leftmost block. 3504. All right, my next deflection is 3344, so I'm gonna record that here, 3344. And then my last deflection on the far right is 2818, so that's gonna go over here, 2818. Okay, so now I need to just go ahead and record my max quadrant. Okay, let's start with our max quadrants. So max quadrant, we solve for up here with our lot alpha 4 square, right? Because we don't need, we could solve for it down here, but we're gonna see that this is gonna be more restrictive than this, right? For our max quadrants and low angle, our lower square weight is gonna be more restrictive than our higher square weight. Okay, so we're gonna go ahead and solve for that. So max quadrant, are associated with our max ranges for low angle. So how many max ranges do we have? We have 2 max ranges, okay? And I see that starting from the left, I have 1 max range that falls between deflection 3504 and deflection 3344, right? So I'm just gonna go ahead and separate that down the middle there, okay? So what range is associated with deflections 3504 to deflection 3344. That's max range 4800, right? So at max range 4800, my quadrant is 364. So I'm gonna record that right here, 364, and always work left to right. Okay, so now that I have that, let's see here. I've got what max range is associated between left deflection 3344 and right deflection 2818. Right, it's max range 6800. So at max range 6800, my quadrant was 705. Okay, so now that I have that, I have my max quadrants. Now I need to work on my min quadrants. Okay, and I know because I'm solving for 2 different square weights, I'm gonna have 2 min quadrants. A min quadrant for my 4 square lot alpha and a min quadrant for my 6 square lot bravo, because that's what we had to solve for, right? So the first one I'm gonna label is min QE for HE 4 square lot alpha. Okay, so min quadrant for HE 4 square lot alpha. My min quadrant, my overall min quadrant falls between deflection 3504 and 2818, right? That's min range 3200. So at min range 3200, what is my min quadrant for 4 square lot alpha? Right here it says it's 231. Let's record 231. Okay. Next, I need to solve, or I need to extract my min quadrant for HE 6 square lot bravo. Okay. HE 6 square lot bravo. So at range 3200, what is my quadrant? It is 235. All right, so now that I have that, just like I solved for 2 min quadrants for 2 separate lots of projectiles, I get 2 different min time fuse settings. All right, so 2 different min time fuse settings. So let's start with lot alpha. So min QE, HE, 4 square lot alpha. Okay, so, no, I'm sorry, correction, not min QE, min time. Min time, HE, 4 square lot alpha, okay? So min time for my 4 square lot alpha was 13.9. That's too easy. Next, I need to solve for min time, HE, 6 square lot bravo. Okay, min time HE 6 square lot bravo is down here, right? 6 square lot bravo, so that is 14.1. See why circling the things we put on our safety T is so important? Yep, so 14.1. And the last thing I need to do is I need to solve for my min VT time fuse setting. And I'm gonna use my most restrictive one. I don't have to have 2 separate ones. And the reason for that is because the universal safety T's that we have as part of like our standard Army issued like documents or whatever, there's not enough space to put two min VT time 2 settings. So we're just gonna always use the most restrictive one. Okay, so what is my most restrictive between 4 square lot alpha and 6 square lot bravo? They're the exact same, right? But I would take the most restrictive one. So we're just gonna record 18.0. Do not forget to add the 0.0 to your min VT time 2 setting, or it will be counted wrong on the exam. Okay, so 18.0. So that means that that is my min VT time 2 setting. Okay, so now that I've completed my safety T for low angle for my range safety card, I need to move on to high angle. So that's what we're gonna do next. We're gonna do our high angle for firing point 166 here for homework 1. All right, so now solving for high angle safety here for firing point 166 as part of safety 1, homework 1, okay? So I'm going to go ahead and get a fresh safety computation worksheet, right? Make sure it says high angle up here at the top because I'm solving for high angle. And I don't have to do a whole lot of work here, right? Because I've already accomplished step 1. I've received the range safety card. I just have to go to step 2, which is go ahead and record the basic safety diagram. But what I can do is I can just take a lot of the information I've already calculated over here for my low angle and just transfer it over to high angle, right? So that's exactly what I'm going to do. So I'm just going to put my low angle sheet right next here, right next to me here, next to my high angle safety sheet. So let's start with the admin data. So location, firing point 166, that hasn't changed. 5309er, 3435. Altitude 376, hasn't changed. Charge 1 Lima, fuse PD. Now for high angle, I only have to solve for fuse PD. I don't have to do VT or time. So I don't need to worry about anything other than fuse PD. So as delayed, no change, 4600. Go ahead and record that down here. Azimuth of delay and azimuth of fire is 4600. Okay, so now I just need to go ahead and construct the base safety diagram. So let's remember, from our range safety card, what did it say that our minimum range was for high angle? It was 3600, right? I don't think in any homework or on any exam, your high angle min range and your low angle min range are going to be the same thing. They're always going to be different, right? So you need to make sure whenever you're computing high angle safety that you pay close attention to what your min range is going to be, right? It's not 3200 in this case, it's 3600. So I'm going to go ahead and start this down here. Okay, I'm just going to go ahead and just draw it out. It's going to start getting crowded again later. That's okay. This is my max range. Yeah, not to scale, just to help, just kind of help visualize everything, right? So they have this. Let's start with our ranges. So min range for high angle, we said was what? It was min range 3600. Min range max altitude. Max altitude we determined at range 3600 was 400 meters. Okay, so we've got that. All right. So next, let's go to our max range. So max range for my dog leg, still same dog leg, right? Max range 4800. Min altitude 400. All right, and up here is max range 6800. Min altitude 420. Okay, so now that I have my ranges labeled, I can go ahead and label my azimuths. So I always work from left to right. So starting over here with my leftmost azimuth, azimuth 4300. I can just go ahead and record the deflections that I calculated too, right? Deflection 3500. But I'm gonna have to recalculate for drift because high angle has hella drift, right? All right, next one, azimuth 4460. Deflection 3340. And I'm eventually gonna have to resolve for that drift as well. And then finally over here, I have azimuth 5000. Deflection 2800. Okay, cool. So now I have my basic safety diagram complete, so I can move on to calculating the actual data down here, right? So charge 1 Lima, shell HE, fuse PD, projectile family Mike 795, which means I'm going to be in the Alpha Romeo 2 TFT, specifically part 1, right? So now, right here, do I have any muzzle velocity corrections or square weight corrections I'm accounting for up here? Not yet. I'm going to do square weight down here, and I don't have any muzzle velocity corrections because I'm shooting a 777 at charge 1. If I was shooting a 777 with any other charge, I would have a muzzle velocity correction. But I'm just shooting it with charge 1, so I know that I don't, right? So let's go ahead and start filling out this portion down here. So this is going to be for 4 square lot alpha. All right, so diagram range, 3600 is our first one, so 3600 plus. Do I have any range corrections? No, I do not. It gives me a total range of 3600 multiplied times range K of 1.0000, because I don't have range K or GFT setting, gives me entry range of 3600. All right, next diagram range is max range 400, my dog leg there on the left. 400, do I have a range correction? No, I do not. It gives me total range of 4800 multiplied times range K of 1.0000. Gives me entry range of 4800. Okay, now I have a max range of 6800 as my diagram range, 6800 plus range correction of 0, because there's no range corrections, right? It gives me total range of 6800 multiplied times range K of 1.0000. Gives me an entry range of 6800. Whew. Okay, so now that I have all of my entry ranges, I can go ahead and start solving for my sight. All right, so high angle sight is the number one thing that gets students on high angle safety. This is the number one thing, right? So make sure that we're doing this deliberately. So before I even try to do anything with high angle sight, I'm going to make sure that I have all of my required materials. I'm going to get out my quick reference guides or my cheat sheets, right? That's going to give me my high angle sight step action drill and what I call my escalation of force. I'm going to make sure that I have my high angle GFT, right? Because I need to use this for my 10 mil sight factor. And if you're the type that likes to calculate angle of sight with your GST, you can have your GST, but like I said, I typically like to do it manually. So let's work on this first one. So for diagram range 3600, remember, because sight is calculated with diagram range. What charge are we shooting? We're shooting charge 1 Lima for all of them, so I'm just going to record that, charge 1 Lima. So what is my VI for range 3600? So remember, VI is target minus battery. So that's 400, target minus battery of 376, gives me a VI of positive 24. Positive 24 at diagram range 3600. Okay, so now that I have my VI positive 24, I need to go ahead and find my angle of sight over 10. So let's go to my scratch paper. So remember that my angle of sight over 10, so remember our equation for angle of sight, right? So this is range 3600, high angle sight is what I'm about to solve for. Okay, so for range 3600 high angle sight, let's find angle of sight. So angle of sight equals VI, so that's positive 24 over range in thousands, which is 3.6 times 1.0186, 24 divided by 3.6 times 1.0186 gives me 6.7 disgusting number. So I know if I look at my step action drill that my angle of sight is always expressed to the nearest tenth of a meter, or correction, tenth of a mil. So that's going to be 6.8. Positive 6.8. Angle of sight will always have the same sign as the VI. Angle of sight will always have the same sign as the VI, whether you're low angle or high angle. Okay, so now that I have my angle of sight of 6.8, I need to find my angle of sight over 10. So my angle of sight over 10 equals positive 6.8 divided by 10. 6.8 divided by 10 gives me positive 0.68, which expresses to the nearest tenth of a mil, which would be positive 0.7. So positive 0.7. So my angle of sight over 10, I'm going to go ahead and record that here, is positive 0.7. Okay, so now that I have that, I need to go ahead and solve for my 10 mil sight factor for diagram range 3600. So how do I do that for my 10 mil sight factor? So I'm gonna look at my step action drill. Okay, for my 10 mil sight factor, it says the 10 mil sight factor is determined using the following rules. For a negative VI, I follow this column. For a positive VI, I follow this column. So do I have a positive or negative VI? It's a positive VI, so I'm gonna follow the column on the right. So it says for positive VI, follow the step action drill below. 1, if the 10 mil sight factor is listed on the high angle GFT, use that value. So let's see if it's listed on the high angle GFT. So I'm going to extract my high angle GFT, and I see that I have diagram range of 3600. So I'm going to set off diagram range of 3600 here in my high angle GFT. This one is brand new, so it's a bit of a pain to... There we go. Okay. So I set it off at diagram range 3600, and I read down for charge 1 Lima, and I look at the red numbers for the 10 mil sight factor, and I see that it is not listed on the GFT. Okay, so it is not listed on the GFT, so that doesn't work, so I gotta move to step 2. If the target range exceeds the last listed 10 mil sight factor, use the last listed 10 mil sight factor. Does it exceed it? No, that would be way over here. I'm actually falling below the first listed range, so that doesn't work. So step 3, if the target range is below the first listed 10 mil sight factor, compute manually. So now I'm not gonna be able to extract it from here. I have to compute it manually, right? So in order to do that, it gives me the equation right here. The 10 mil sight factor for a positive VI is 10 multiplied times 1 plus the complementary sight factor, right? So let's go ahead and just set that equation up here on our scratch paper. Turn the music down just a little bit, okay. So let's see here. We said for positive VI, remember this is important because the equation is different for positive and negative VI, right? For positive VI, 10 mil sight factor is equal to 10 multiplied times 1 plus my complementary sight factor. So where do I get my comp sight factor from? I get that from table golf, right? So it's going to extract my Alfa Romeo 2. Let's refer to table golf. All right. Now I'm shooting high angle, so I got to be below the rockstar line. Everything down here is high angle, right? So make sure that I'm extracting from the correct side of the rockstar line. So the 10 mil sight factor, and I'm looking, the complementary sight factor I'm looking for at diagram range 3600. Is 3600 a listed value down here? No, it's not. But it falls below the first listed value, so I'm just going to use the first listed value, right? So that's range 4000, and I see I can extract from either column 1-2 or column 1-3. Now, what am I? Am I target above gun or target below gun? Well, I have a positive VI, so I'm target above gun, so I'm going to pull or extract from column 1-2. So that means my complementary sight factor is negative 1.085. Okay, so negative 1.085. So now I just have to plug this into my calculator. So let's go ahead and solve for this. There's gonna be 10 times. So that 1 plus negative 1.085, the plus and the negative, just turn that into a minus, right? So that's 1 minus 1.085 gives me negative 0.085. Multiply that times 10, and that gives me negative 0.85. And if I look at my step action up here, it says that I need to express it to the nearest tenth of a mil. Okay, so negative 0.85 expresses to negative 0.8 as my 10 mil sight factor. 10 mil sight factor is always negative. So if I get something other than a negative number right here, I need to stop and then go back up here and double check my work. The 10 mil sight factor is always negative, okay? So negative 0.8, let's go ahead and record that down here. Negative 0.8. Okay, so now I just multiply my angle of sight over 10 times my 10 mil sight factor. So I do positive 0.7 times negative 0.8, which gives me sight of, I think I inputted that incorrectly, 0.7 times 0.8. Yep, there we go. It gives me, it's going to be negative 0.56, and sight is always expressed to the nearest mil, so that is negative 1. Okay, sanity check time. So for high angle sight always has the opposite sign of the VI for high angle, right? So if my sight is negative 1 and my VI is positive 2.4, that passes the sanity check, right? This should be the opposite sign for high angle. Okay, cool. So now that I have that, let's go ahead and calculate the sight for diagram range 4800. So 4800, what is my VI there? So remember, VI is target minus battery. So let's see here, at 4800, it's target 400 minus altitude 376 for the battery, which gives me a VI of positive 24. Okay, now I need to find my angle of sight divided by 10. Okay, so diagram range, so it's range 4800, high angle sight. Okay, so range 4800 high angle sight. So angle of sight is equal to VI, which is positive 24, over range in thousands, which is 4.8, multiplied times 1.0186. So that's 24 divided by 4.8, multiplied times 1.0186. So that gives me 5.093. I know angle of sight is always expressed to the nearest tenth of a mil, so that is positive 5.1. Angle of sight is always the same sign as VI, regardless if it's low angle or high angle, right? So positive 5.1 and positive 24. Makes sense. Okay, so now I just need to get my angle of sight over 10, which is positive 5.1 divided by 10 equals, so 5.1 divided by 10 equals positive 0.5, because that's always expressed to the nearest tenth of a mil. All right, so positive 0.5 is my angle of sight over 10, so positive 0.5. Okay, so now that I have that, I need to find my 10 mil sight factor. So to do that, I go and refer to my step action drill. So for the 10 mil sight factor, use the following rules. For negative VI on the left, positive VI on the right. I have a positive VI, so I'm going to use the right. So follow the step action drill below. Number 1, if the 10 mil sight factor is listed on the high angle GFT, use that value. Okay, so let's see if it's listed on the high angle GFT. All right, diagram range 4800, using our feats of strength, let's go ahead and find diagram range 5, 6, 7, 8. Okay, diagram range. Okay, so now that I have that, I set that off and I read down, making sure I'm reading charge 1 Lima. For the 10 mil sight factor, the number's in red. It looks like 1.7, negative 1.7 is my 10 mil sight factor. So if it's listed on the high angle GFT, use that value. So it's listed, so I can use that, right? I don't have to do any math. Awesome. So that means that my 10 mil sight factor is negative 1.7. 10 mil sight factor is always negative, always. Okay, so now I take angle of sight over 10 multiplied times my 10 mil sight factor. So that's 0.5 times 1.7 gives me 0.85, which we always know sight expresses to the nearest mil. So that's negative 1. Sanity check time. A high angle sight has the opposite sign of the VI. So high angle sight of negative 1, VI of positive 24, that checks, right? That passes the sanity check. All right, so now we just got to find high angle sight for diagram range 6800. So let's start off with my VI. So what is my VI for diagram range 6800? VI is target minus battery, so that's 420 minus 376. Gives me a VI of positive 44. I need to find my angle of sight over 10. I like to do it manually. Okay, so let's go ahead. So this is range 6800, high angle sight. Angle of sight is equal to VI, so that's positive 44 over range in thousands, which is 6.8 times 1.0186. 44 divided by 6.8 times 1.0186 gives me 6.5909411. We always know this expresses to the nearest tenth of a mil, so that's 6.6, right? And it's for angle of sight, it's always the same sign as the VI, so positive 6.6. Okay, so now I just need to find angle of sight over 10, which is equal to positive 6.6 divided by 10, which gives me positive 0.66, which expresses to positive 0.7. That's my angle of sight over 10. So positive 0.7. Now let's find my 10 mil sight factor, okay? So let's see here. If the 10 mil sight factor, so I have a positive VI, right? So if the 10 mil sight factor is listed on the high angle GFT, use that value. So let's go ahead and extract our high angle GFT. At diagram range 6800, using our feats of strength, 6, 5, 6, 7, 6800. Okay, so at range 6,800, all right, it doesn't look like my 10 mil sight factor is actually it's not listed there. So let's see what it says. If the target range exceeds the last listed 10 mil sight factor, use the last listed 10 mil sight factor. Okay, so it exceeds it, right? So I just have to use the last listed value, which is on my 10 mil sight factor line, which in this case is negative 2.2. Okay, so negative 2.2 is my 10 mil sight factor, negative 2.2. Okay. So I just multiply these two things together. So negative 2.2 times 0.7 gives me 15.4, right? Negative 15.4 expresses to negative 1.5. So I need to check time. Is it the opposite sign? Is the sight the opposite sign of the VI? Yes, it is. In high angle, it's always the opposite sign. Cool. So now that I have that, now that the significant emotional event of high angle sight is complete, I can move on to everything to the right of the solid black line, which means as soon as I'm crossing this line, I'm going to go ahead and grab my Post-it note and cover up all of my diagram range values just to leave my entry range, okay? Because everything to the right of the solid black line uses entry range. All right, so let's go ahead and find our elevation for entry range 3600. So let me extract my Alfa Romeo 2. Elevation is found in table Fox. All right, I'm shooting high angle, so I'm going to ensure that I am below the Rockstar line. So looking for range 3600. All right, so at range 3600, I have elevation 1294.0, which expresses to elevation 1294. Quadrant is the summation of elevation and sight, so 1294 minus 1 gives me 1293. And quadrant is a safety T value, so I'm going to go ahead and encircle that. Now I need to go ahead and find my drift. Do I need my drift here? Yeah, I need my drift at my lowest min range and my highest max range. So drift at range 3600. Let's see here. I look in here. Drift in column 8 is 134.8. Wow, that's a lot of drift. Okay, 134.8 expresses to 135, and drift is always to the left. Left 135. Drift is always to the left. 135. Okay, so now what do I need at entry range 4800, right? Do I need my elevation and quadrant? Yeah, I absolutely do, right? Because it's a max range, so I got to find my max quadrant there. So entry range 4800. Let's turn the page. Entry range 4800 gives me an elevation of 1194.6, making sure I'm staying below the Rockstar line, right? Because I'm high angle. So 1194.6 expresses to what? That's 1195. Quadrant is the summation of elevation and sight. So 1195 minus 1 is 1194. Do I need my drift for this range? Nope, I only need drift for my lowest min and my highest max. So I don't need that. Okay, so now entry range 6800. Entry range 6800, I need my elevation because this is a max range, right? So elevation at entry range 6800 is 866.3, which expresses to 866. Never trust my mental math. So let's do 866 minus 15 to find our quadrant of 851. Okay, and I also need my drift because this is my highest max range. So drift at range 6800 is left 27. Left 27. Okay, so now that I'm done with this, I can go ahead and remove my Post-it note. It's safe for me to look at my diagram ranges again. And now I can just go ahead and apply my drifts up here, right? So let's start with the left deflection. With deflections, I always work my way from left to right. So looking at deflection 3500. So that's on this line right here. So deflection 3500, what side is open? To the left or to the right? Yeah, right, looks closed. So it's open to the left, using least left, most right, least left. Yep, so that's least would be left 27, right? My least meaning my smallest number, so left 27. Remember, Lars invented deflection. He's an asshole. So 3500 plus left 27 gives me a left deflection of 3527. It's a safety T value, so I'm going to go ahead and circle it. Let's move on to the next one. So deflection 3340. So deflection 3340, which side is open? To the left or to the right? Right looks closed, open to the left, least left. Okay, so least, so that's left 27. 3340 plus left 27 gives me 3367. Safety T value, so I'm gonna circle that. It's still crowded, okay. Now I have my last deflection over on the right. So deflection 2800, which side is open on that deflection? To the left or to the right? Left side looks closed because that's the box. Right side is open. So most right, least left, most right. So my most drift is left 135. So left 135. So 2800 plus left 135 gives me 2935. And that is a safety T value, so I'm gonna go ahead and circle that. Okay. Now, I know it's out of order from what we do in class, but as soon as I get my drifts, I always like to apply them so I don't have to worry about it and go back later, and I don't accidentally extract the deflection without the drifts applied to it whenever I calculate my safety T. So I always like to do it right here, okay? So now that we have this, we need to go ahead and solve for a square weight correction, right? Because we have 6 square lot Bravo, right? 6 square lot Bravo. So just like in low angle, right, we had to find the min values for a higher square weight. High angle, everything is pretty much opposite, right? It's because my highest quadrant is going to be associated with my lowest range. So what that means is instead of finding a new min quadrant for high angle, I'm going to find another max quadrant for high angle, right? So max quadrant will be at the min range line for 3600, right? So diagram range 3600. I don't need to worry about finding min quadrants for max ranges, right? And you could if you wanted to, but you'd see that these are going to be more restrictive up here for 4 square, right? So for high angle, I just need to solve for all of my min range values. I don't need to solve for my max range values, right? So same thing as low angle where I find my min range values. It's just going to be a max quadrant. Remember, because the higher quadrants are associated with the lower ranges for high angle, okay? So for diagram range 3600, we're shooting charge 1 lima. The non-standard condition is 6 square minus the standard condition of 4 square, which gives us an increase of 2 squares. Okay, so now I need to find the range correction. So range correction, I go to table Fox, ensuring that I am below the rockstar line because I'm shooting high angle, right? So range correction at diagram range 3600. So let's find it. Yep, so diagram range 3600 over here on page 131. I look over to the right. Do I have an increase or decrease? I have an increase, which means I'm going to extract data from column 19, right? The increase column. So that is positive 16. Okay, so I extract the data or the value of positive 16. So now I do the math. So I take 2 squares times 16 gives me positive 32. Always record the raw value out of your calculator for the range corrections. So positive 32, and then that expresses to the nearest 10 meters, which is positive 30. Okay, so positive 30. So too easy. That's the only one I have to do, right? So now that I have that, I can go ahead and come down here and solve for that value that I need. So what is my diagram range? Diagram range I'm solving for is 3600. Do I have a range correction? Yes, I do. 30, which gives me 3630. Multiplied times range K of 1.0000 gives me an entry range of 3630. Okay, so now that I have that, I need to go ahead and find all of my site. But remember, site is a function of diagram range, right? So what does that mean? That means as long as I calculated this up here correctly, I can use the site from the diagram range 3600. I don't have to go ahead and recalculate it all, right? So for charge 1 lima, I'm just literally gonna pull all this down. VI is positive 2.4, angle of sight is positive 0.7, 1 mil sight factor is negative 0.8, which gives me my sight of negative 1. Just making sure that I accurately record all that data, okay? So now I just need to find elevation for the range 3600, but I'm crossing my solid black line, right? Which means what? I'm gonna be using entry range, everything to the right of the solid black line. So I need to go ahead and grab my Post-it note and cover up my diagram ranges, right? Because I'm going to be using entry range. So entry range 3630, what is the elevation for high angle 3630? It's not listed to 100 meters, so it means I'm probably going to have to interpolate, but let's find out. So let's go ahead and refer to table Fox in our Alfa Romeo 2. Staying below the rockstar line because I'm high angle, right? And let's see here, I need to find elevation for that range. Okay, so range 3630, is that a listed value? Range 3630, it is not a listed value, so I'm gonna have to interpolate for it, okay? So let's get out my scratch paper. And this is gonna be finding elevation for high angle range 3630, okay? So I'm trying to find 3630. It's not a listed value, but what values does 3630 fall between here in the TFT? Falls between 3600 and 3700. Now, this is super, super important. Whenever we are setting up our interpolation for high angle, we interpolate from top to bottom as listed in the table. So as listed in the table, 3700 is on top of 3600, right? So we're gonna put 3700 up here and 3600 down here, okay? Make sure we don't flip those. I can go ahead and set up my brackets if I wanted to. So what does it take to get from here to here? That's 70. It takes from here to here is 100. Okay, I'm trying to solve for elevation at 3630. I don't know what that value is, but I do know what the value is for range 3700. At range 3700, it's 1287.2. 1287.2. For range 3600, it's 1294.0. Going to set up my brackets here. I don't know what this one's going to be, my little bracket, but I can go ahead and solve for this one right here. So that's 1294.0 minus 1287.2. I always use absolute values so I don't have to work with negative numbers, so that's 6.8. All right, so now that I have my brackets, I go ahead and set up little over big equals little over big. So little bracket over big bracket equals little bracket over big bracket. Okay, so now I cross multiply, so 6.8 times 70 divided by 100 equals 4.76, and express at the x. Express at the x as listed in the table, right? So in the table, in this column, they're expressed to the nearest tenth of a mil. So I'm going to express this to the nearest tenth of a mil. So 4.76 expresses to what? 4.8. Okay, so 4.8. So now that I've expressed at the x, I take this and I plug this in here to make whatever value I'm trying to solve for fall between 1287.2 and 1294.0. So in this particular case, I'm going to add it. So 1287.2 plus 4.8 gives me 1292.0. 1292.0. Okay, so elevation 1292.0. Sanity check time, does that fall between 1287.2 and 1294.0? Yes, it does. So that passes the sanity check, okay? So 1292.0, let's go ahead and move that over here and express it as we extract it. So that's 1292 is my elevation. So now that I have that, quadrant is the summation of elevation and site. So I just need to take elevation 1292 and add my site of -1, which gives me 1291. All right, and quadrant is a safety T value, so I'm gonna go ahead and circle that. And do I need to find drift? Nope, because I only find drift for my initial diagram ranges, or my initial ranges up here. So I don't need that. Okay, so I'm done with this. Go ahead and remove the sticky note. I don't need to do any more math down here. All right, so now I've completed step 3. Now I just need to move on to step 4, which is issue the safety T. So let's go ahead and record our safety T data. So location is firing point 166 at 5309, 3435, altitude 376, charge 1 Lima, shell HE, fuse PD. Azimuth of lay, we said was 4600. Okay. So let's go ahead and find all of our values. I always start with deflection, right? Always start with deflection. It makes it easier. So I'm going to go ahead and label deflection. How many deflections do I have? I have 3 deflections. So I'm going to go ahead and separate the deflection block into 3 separate blocks. Starting from left to right, I have 3527. So I put that one on the left. 3527. I have 3367 is my next one. 3367. Then I have 2935 as my far right, my last one. 2935. Okay. So after I have my deflections, let's go ahead and find our minimum quadrants, right? So remember, for high angle, min quadrant is associated with max range, right? So we found our max ranges of 4800 and 6800. And we only solved for 4 square lot alpha, right? So we're just gonna record min quadrant for HE 4 square lot alpha. It's a lot of erroneous information here, but I just like to stay super organized, right? So min quadrant HE 4 square lot alpha. So let's find our first one, right? Which is our max range that falls between deflection 3527 and deflection 3367. So what is the max range between those two? That is max range of 4800. At max range 4800, what was my quadrant? It was 1194. So we're gonna record 1194 on the left. On the right, what was my max quadrant? So max quadrant that falls between deflection 3367 and 2935, or correction, min quadrant at the max range that falls between 3367 and 2935, which is what? That's max range 6800. So 6800 has a quadrant of 851. Okay, so now my min quadrants are complete. So after I'm done with that, I just need to find my max quadrants, right? And I've got 2 max quadrants. See here, right? So the first one I'm gonna do is I'm just gonna record max quadrant for HE 4 square lot alpha. We said our max quadrant for high angle is associated with the minimum range line, right? So min range 3600 is quadrant 1, 2, 9, or 3. Let's just record that there, 1, 2, 9, or 3. Then I need to solve for max quadrant HE 6 square lot bravo. And that was down here of quadrant 1, 2, 9, 1. All right, so that completes the safety T portion of my high angle safety for homework 1.